Okay, everyone, are we ready to start? Good to see so many people here. I'm Rob Moody. I'm the manager of strategic partnerships at Matrox Video. And for the next 45 minutes, I'm not talking about Matrox. I'm talking about the emergence of IPMX, the IP media experience, and what it's going to mean to all of us. It's premised on the fact that for the last 3 decades or so, the real-time media that we've run around events and facilities has generally been in the SDI format, and it's been carried over coaxial cable. The identical technology that was found in the Pro Video studios at the top tier. And for many of you, I guess the bulk of the equipment that you've got is going to be based on SDI. The world's changing, and those studios that we've emulated for so long are transitioning away from SDI and coax, and they're moving to a distribution methodology using IP networks. The move started several years ago. It's been going on since 2017, really. And that means that if it hasn't affected you yet, it probably will do eventually. And at the top tier, this is manifested by the SMPTE standard ST2110. But let's start with SDI, because that's where we are. And let's be clear that the broadcast and the studio community haven't abandoned SDI altogether. Still good, very good for small installations. Neither is it being ripped out of big and medium-sized installations ad hoc. It's being looked at when things get to end of life. But at that point, IP networks are becoming the norm for the medium and the large installs. And these are some of the reasons why broadcasters and the studios are drawn to using IP networks in preference to their SDI. I'm not going to talk through them. You all know that SDI has got limitations as well as strengths. Fundamentally, what they were looking at was a network and said, well, yeah, I can see flexibility, I can see scalability that I haven't got. I'd like to be able to use that. And so they were looking for something that could fully exploit all of the flexibility that they get with the networks that their IT colleagues were using. Now, an important part of the broadcast world is that it's hypercritical that what one broadcaster does can be used by others in different geographical locations. So they have standards, so they all do it the same way. And the Global Learned Society for High-End Video, SMPTE, the Society of Motion Picture and Television Engineers, asked the industry to make some proposals as to how they would move content around facilities using IP networks. Identified a number of key needs, one of which was to be able to move a 4K video in studio quality live, or in different words, uncompressed and with no latency. And that particular challenge derailed a number of the proposals that they received. Many were discarded because either they introduced artifacts that weren't acceptable, or they introduced latency, or both into that 4K ultra-high definition material. So of all the proposals, they chose one, they refined it, and subsequently codified it as a SMPTE standard ST2110. And slowly but surely, since 2017, that's rolled out into the world. Rolled out, Rob? Are you sure? Who's using it? Is it big? Does it work? Very visible recent one that we've all seen. Warner Brothers Discovery were fully ST2110 for the Paris Olympics. I'm told they had approximately 300,000 endpoints, NMOS endpoints, in that one installation alone. So I offer that as evidence that A, it works, and B, it works at scale. 300,000 endpoints is scale. That's the name of the standard there, and note that it includes the over IP, over Internet Protocol. It's for moving media, and it moves the media as 3 separate streams, or essences as we refer to them. The audio, the video, and the metadata are all sent as independent streams, so you can process them separately if you need to. You can route them separately if you need to. Now, devices that support 2110 ultimately will become native 2110, only having network connections. Today, there are lots of gateway devices that connect baseband formats like SDI into 2110, and as we will hear, into IPMX as well. IPMX, incidentally, is based on ST2110. That's why I've started talking about it. They're interrelated. And those gateways allow users to transition their installation, their fleet of equipment, step by step, still keeping equipment that's got life left in it, but upgrading kit as and when they need to, moving in the direction of their own strategy, or indeed, if they haven't got a strategy, at least moving forward. Essences, that's an important point. So without going into the maths, A single UHD 60 signal with 8 bits per pixel needs a data rate of about 12 gigabits per second. You've all heard of 12G SDI, that's what the 12G means, 12 gigabits per second. To transport uncompressed UHD 60, you need something that can deliver that sustainably. Clearly that's not a 10 gig network. It would need to be either a 25 gig network or 2 10 gig lines in parallel. And that's a much bigger pipe than the IT colleagues we mentioned earlier have been traditionally using. And that shows, of course, in the technology. 25 gig is based on fibre optic rather than on copper cables. Synchronisation is important when we work with video. The idea of house sync or black burst is traditional in the video installs that we work with. It's well established. And in order to replicate that, the network has got to be able to tightly align the endpoints, tighter than the way the normal IT people would use to synchronise all the clocks that we enjoy seeing in the corner of our taskbar. What they did was they adopted an existing IEEE standard known as PTP, Precision Time Protocol, which would enable them to have the degree of synchronization that they looked for. And that rolls into IPMX as well. You'll see the commonalities emerging. And that decision using PTP meant that ST2110 is outside the experience of the typical IT department, the people that they thought they were going to rely on for help. And it suddenly means that us have a different set of IT skills to those in our IT department colleagues. To make PTP fly, you need to have people with advanced networking skills, or perhaps, dare I say it, networking for AV or networking for broadcast. This is a growth opportunity for all of us here. And you need PTP-aware networks, switches, routers and so on that support it. The inevitable happened. The network for moving the video needed to be different from that was moving the IT. Convergence wasn't quite as everybody expected. And you'll sometimes hear it called operational technology, OT, rather than IT for information technology. It's for doing what we want it to do. IPMX will support that if it's there, because being compatible with 2110 was one of the objectives. But if it's not there, it's a simpler network. It's a conference centre that you're working with their network. IPMX gives you other options, including running totally asynchronously, meaning running under your own steam without awareness of other people's timing. Nothing new there, that's what HDMI does. But it lets the network be an ordinary network with ordinary switches and regular network techs if that's what you need. We started with 2110, and that started from uncompressed. I explained how that worked. But they soon realised not everybody in a facility needs absolutely perfect video. And moving content between facilities rarely needed to be uncompressed either. So ST2110 added a category for compressed streams, content that could still be considered real time, but was less demanding in network bandwidth. Content that could still be edited and switched at whatever point you wanted without causing images. And the industry found that JPEG XS, a codec so standard that it's got an ISO spec number, fitted the bill very, very well. And with a latency of less than a frame, a bandwidth of, say, 2.5 gigabits per second for our UHD 60 we started thinking about, it rapidly became a de facto standard. It wasn't written into the spec, but everybody was using it. Alongside their uncompressed streams. And it could even be used for very respectable video on a 1 gig network if need be. And this idea, multiple formats, different bandwidths, different user needs, tees up the discussion for IPMX. So what is it? What's it for? In a few words, it's a suite of published international standards and open specifications. Open standard for short. And the purpose of it is, as we said, to move the real-time media, the audio and the video, across IP networks. I've highlighted 3 important words on this screen here. Open, meaning it's not controlled by a single manufacturer or a self-defined group of manufacturers. I've highlighted real-time, meaning either it's play out, say from a media player, or it's live. And I've highlighted interoperability, meaning you've got the ability to join up systems and devices, connecting islands that are separated by their technology. I've said islands, some in the industry call it a proprietary silo, some call it a walled garden, but the practical effect is they can't talk to each other without going through some sort of broker. Give you an example of that in case you need one. Maybe you've got a group of people in one department of your client which has got some H.265 players, and they don't understand either the H.264 streaming encoders in a second department or the NDI cameras in a third department. They might all be AV over IP, they might all be the same brand, but they're separated by technology. And the traditional broker approach would be to exit the first system, say as HDMI, then re-encode that into the second system. And that action takes it out of the network. It's no longer AV over IP because HDMI isn't in the network. You can't enjoy the routability, the protection, the monitoring and so on. Big advantages of the AV IP. So interoperability isn't just about being cross-brand, as a lot of people think. It's also about cross-technology. So, where does it come from? If you happened to be in Barcelona a few weeks ago for the ISE show, you might have seen this. It's a booth dedicated to IPMX, and this image graphically tells you something about where IPMX comes from. We see AIMS, the Alliance for IP Media Solutions, and they're supported by VSF, the Video Services Forum, and it was them, the VSF, who wrote the technical recommendations that defined IPMX. Also supported by AMWA, the Advanced Media Workflow Association, and they created a specification called NMOS, and that lets the media devices be discovered, registered, and then connected to each other. All of these are not-for-profit bodies. None of them are owned or controlled by manufacturers. So this is giving us a clue as who's behind it and who's what's it based on. And if anyone asks you, who actually is behind it, AIMS is probably the best answer. AIMS is the alliance that owns the trademark, IPMX. They're the people who coordinate the marketing and the project management of IPMX. Personally, I'm part of the education work group of AIMS. Now, I've already highlighted some specific stakeholders in this slide. There are others. SIMPTE, we've mentioned them before. AES, the Audio Engineering Society. EBU, the European Broadcasting Union. That's three additional well-known ones. And they're not manufacturer-controlled either. Now, of course, manufacturers are also stakeholders, but none of them have got a guaranteed seat at the table when things get decided. I'm from Matrox, so clearly Matrox must be involved, right? And our experience allowed Matrox as a leading manufacturer to be the first to bring IPMX endpoints to market. That's a couple of years ago now. And be clear, we're very good at what we do. But IPMX does not belong to Matrox. It's an open standard, and make no mistake, our people have contributed some significant expertise through the bodies I've just mentioned. So Matrox has definitely got an iron in the fire, a very, very big iron, but it's not our fire. One more thing to learn from this slide. Because it's an open standard, the manufacturers who adopt it don't actually need to join anything. They don't need to buy anything. They don't need to subscribe to anything. And many in our industry, your customers perhaps, maybe even you doing due diligence, often seek out membership lists like these that were shown on the booth because they believe wrongly that it tells them who's adopting it. And those who for their own reasons want to slow down IPMX or otherwise discourage it tend to compare these lists with lists of adopters. They're comparing apples with oranges. So it's a bit misleading. You might want to consider this. The TV1, a big brand. You can see their booth over there. They were actively describing their products and the Green Hippo products as supporting IPMX. They're not on any of these three lists. So it's an open standard. Anyone can download it for free and use it. It also means, incidentally, that AIMS can't actually say for certain who's adopting it because nobody has to tell AIMS. We've got a good idea, but we haven't got an absolute list. So we've got a lot of stakeholders there. What did they do when they got together? Premise is very simple. Add to ST2110 the features that AV need, features that live events need, that are not already there. And to do so without breaking what's already been proven, because that's important. Don't want to reinvent the wheel. Example, ST2110 users tend to think of video as being YUV. They tend to think of it as 422, 10-bit. AV folks would say, yeah, but what about RGB? What about 420 and 444? 2110 users would say 16 by 9. AV would say, well, yeah, what about 16 by 10, 32 by 9, and a whole bunch of other stuffs? My projectors aren't native 16 by 9. I can't use that. 2110 users are always striving for the very highest quality. It's part of their, they have a mission to protect quality. AV and live events would say, well, yeah, that's good, but I've got lots of use cases where I can accept some compromises to latency, to image quality, and so on. And ST2110 users would probably think that the metadata they inherited from SDI is all you need to worry about. But what about the info block in HDMI? Yeah. What about HDCP? There's lots of other things that can be included. And what VSF set out to do, we mentioned them earlier, they took the foundation of 2110 and they produced a suite of recommendations, technical recommendations that adds the bits that all these other folks would have deemed missing in 2110 that would make 2110 more useful to them. And they created IPMX. So IPMX is an expansion, a superset of ST2110. I've emphasised that point because a lot of people run away with the idea it's a subset, and it's not, it's an expansion. And to do that, they created a series of documents that set out what needed to be done. And if you went to the VSF website, you would see this list of documents, and you're all free to download all of them. It includes both drafts and final released versions. It's an open standard. As I said, you don't need to join anything, you don't need to subscribe to anything, you don't need to pay a license. Incidentally, a lot of folks say, well, it's emerging, when's it going to be real? 7 of these were released in February 2024. That's the point that IPMX became real over a year ago. You can probably discern there's a number of the items there. They've got a draft on the end. They're still coming. They're works in progress. A lot of folks say, well, isn't that a bit of a problem? We're working with something that isn't finished yet. You usually answer that question in this way. Did we all start using HDMI before it did 4K? Yes, we did, because it was very useful for full HD. Did we all start using HDMI before it did audio? Yes, we did, because it was very good for supporting video that we were using. Should point out that IPMX does 4K and audio, but you get the idea. Having work in progress isn't a problem. HDMI is still evolving and we're still using it. IPMX is usable for projects. It's already being deployed, including a variety of different industries. So, as I've said several times, it's an open standard. You can download all of it in full here from VSF. Remember, their name was on the wall in the image earlier. I'm not expecting you to actually want to read them, but so that you know where they are, should you want to read them, or if your clients say, I want to learn more about that, it will be in the video. There's the website of the VSF there. You go to the technical recommendations area, and that's exactly what you'll see, and you can download any of them. I also highly recommend their review of codecs, which is there. That's a worthwhile read for all of you, I think. I certainly enjoyed it anyway. But not all users need uncompressed. So with compromises, different sorts of users can use networks other than the 25 gigabit per second. And the values that I'm showing here on this screen are for 8-bit UHD 60. In general, latency increases as we go down the table because more processing is being done, but not always so. What I'll do now is I'll position some names onto that framework that you'll recognise. You can see that at the top, in the first row, uncompressed, we've already mentioned that. The rows below those are different amounts of compression. Nothing particularly scientific about it, but you can see the bandwidth is reducing. So in the lightly compressed environment, that's aiming to get as much as it can out of a 10 gigabit per second. So you'll find that JPEG XS lives here, as does SDV over E, Extron's nav. moderately aims to get as much quality as it can out of a well-provisioned 1 gig network. Here you're going to find codecs like JPEG 2000, Crestron's MVX, JPEG XS again, Nav again, and Dante AV Ultra are all here. It's aiming to put less demand on the higher layer elements of the 1 gig network, the connection between the layer 2 switch and the layer 3 router. And it's aiming to sacrifice a little quality maybe, add a little latency, reduce a switching speed perhaps, to reduce cost. And important to realise that that's where the some of the cost of our AV over IP lives in the network. So we've got our lightly compressed, our moderately compressed, and the highly compressed. This is where H.264, HEVC, the other Dantes, and all of the NDI variants live in that highly compressed, and Teams and Zoom, of course. Now, no single codec can be optimized for everything, and that's exactly why manufacturers like us have a variety of AV over IP solutions to cater for the different needs. And of course your inventory needs to do that as well. What's IPMX? Well, IPMX can be all of them. The published IPMX already addresses the top 2 rows. The third, moderate compression, is already addressed in an IPMX ready sort of way, which means that bit of the spec is not released, but there are products based on it. And the highly compressed layer will be along very soon. There's already products arriving there, for example, showing HEVC and H.264 as well. But IPMX is not a single codec. IPMX is a single system that can produce multiple codecs and will suit whatever network is deployed or might be deployed. It's giving options, and that's quite dramatic when it comes to terms of designing something for someone. You can have the lower cost 1 gig only units, but they'll work at a network level with units intended for the higher bandwidth applications. It won't do uncompressed, of course, because it's a 1 gig system. But IPMX is the only AV over IP approach that uses the same format as ST2110. And it's the only one that lets your inventory address the top-end studio grade and the regular AV clients. So what can we associate with IPMX then? It's the widest story. It does uncompressed 4K 60 now, as well as the lightly and moderately compressed now, with the promise of the highly compressed imminently. One approach covering all the different categories of user compression needs. None of the others offer this. None have got such a wide footprint. And it will be very difficult for something that was designed for the bottom of the pyramid to work its way up the pyramid. It's much harder to climb a mountain than it is to come down a mountain. So those that were designed for a 1 gig bandwidth, it's a challenge too far to say, I'm going to do 25 gig uncompressed. And remember, this includes direct compatibility with 2110. Of course, not everyone wants uncompressed, I just said that. But if there's a possibility, then the system has got to be possible to be configured to do it. That's what IPMX is bringing. It's bringing options. And it's not just complicated stuff like what is the compression. Some AV solutions anticipate camera resolutions only. We mentioned the 16:10 need. It's not in all of them. EDID, it's not in all of them. But our world is sort of premised on it. That PTP, the Precision Timing Protocol, an IPMX unit, if it sees it, it has an option to behave as an ST2110 endpoint. So I was speaking to the guys on from Novastar earlier. Their wall controller that's looking at ST2110, if it saw that, it would recognise that and deliver products to them. That has an effect on the switches you use in the network. But there, as I said, there are options. If it can't see the PTP, it's got the option to behave in other ways, either a lower spec PTP or asynchronously, meaning you don't need the more expensive switches, you don't need the text to be PTP savvy. Now you may find that some of the others are trying to assert their dominance through perhaps the control plane. You can have lots of different brands, but you must use our control software. Here's the license. The IPMX does not do that. Remember I mentioned NMOS? That's a non-proprietary discovery, registration and control set. And that means that, say, Matrox control software can work with Cobalt or Plexus or Barco hardware that's also IPMX, and vice versa. As well as all the ST2110 products that you might find at an IBC show, say. And for the very first time, an implementation of HDCP that can have different brands at near and far end across a network. It's been implemented to pick up the bits that the HDCP organisers defined what sort of keys were needed, but not how to share the keys. That's one of those TR10 specifications called HKEP, the HDCP Key Exchange Protocol. Simple reality, an IPMX product does not have to have all the features that the standard defines, but if it does have those features, you must do it the IPMX way. That's what makes it IPMX. That's what creates the interoperability that we're looking for and the broad spread of acceptability. So, I said they weren't ripping things out, and it was happening bit by bit. How long is that changeover going to take? Well, we can look to what happened with audio over IP when that happened. Dante, Ravenna and others, well established for audio over IP. And now we're looking at this same over IP thing again. But it's not the same again. It'll phase in, but the taper will be quite short. Video is actually a lot harder to move than audio is. Now I'm going to throw a trend in here, and it's one you've almost certainly noticed. Think about the connectors around the edge of your mobile phone. Are they different to those on your previous models? And the answer is pretty certainly yes, they're different. They're different and there's not as many of them. Same question, does your current laptop have the same connectors as your previous laptop? Same premise, you're probably thinking, yeah, I can't even say for sure it's got HDMI on unless I've looked, because that used to be a given, now it isn't. When you look behind the television in your lounge, do you wish you could get rid of some of the cables? Yes, we all do. And that's the sort of trend we're talking about. And those have all happened over the period that you change your phone, you change your laptop. 3, 4 years. That's how fast it's happening. The futurists that I've spoken to have told me that in their view, the AV products, the sort of products that we buy and maybe our clients buy, within a few years, most of those new products are going to have only 2 connectors on them. One's likely to be a USB derivative intended for in-room communication, and the other is likely to be a network connector of some sort. Whether it's copper, glass or wireless doesn't matter, but you've got 2 fundamental sorts of networks. And the network one is going to be room to room, room to building, building to world. Of course, it also does in-room as well, because networks do. But that's fairly radical. All the things that we've built up our skill set in over the years, VGA, DVI, the HDCP, RCA, SCART, if you want to go back that far. Yeah, all of those are going to be fading away over that same sort of period. It will never happen in 5 years, Rob, but you've just proved to yourself that it's happened to your phone and your laptop. So, 5 years sounds scarily possible to me. And 5 years is less than the amount of time that the equipment we're buying today is going to be in service. So we need to be thinking, this stuff I'm buying today, how's it going to be connecting to the stuff that's on sale in 5 years' time? That's where we want the options. That's the flexibility that we're trying to get. That's what IPMX is bringing to the table. So I think networks are pretty much unavoidable, proliferating rapidly. And there's another way it shows up in your lives, and that is cards that slip inside large format panels, projectors and the like, generally into the Intel SDM slot, because those sort of devices can bring IPMX straight into the display device. And that revolutionizes the amount of cables that need to be laid in terms of an installation. There's the general philosophy. So we can take ST2110, we can take the uncompressed IPMX, pretty much the same thing. We can take the JPEG XS that comes in through ST2110 or JPEG XS again directly into our display device simply by a card. And as IPMX develops, more and more potential sources join the palette of sources. And of course, there will also be gateways that allow you to put SDI, HDMI, HD-based T, NDI, all these other things that we have as our staples today into that IPMX transport. Because this isn't a rip and replace, this is a transition in your strategic direction. Another arrangement there. So you've got to imagine an event where you've got lots of repeater screens now, and we want to show the same content on multiple screens. They're too far apart to use the HDMI loop through that's built into the screen. So in the old days, we would have used a distribution amplifier. Nowadays, we'd probably be thinking about AV over IP, and we'd use the network for the distribution. So we could have a big switch with one port for each display. For sake of argument, let's say there's 36 repeater screens, just too many for a 32-port switch. So we've got to have either a big switch or lots of switches. That works. You can multicast, they'll all see exactly the same media. Alternatively, you could put something different on each of the screens. And if you disconnect one network cable, you'll lose one screen. Or you can do what's pictured there and have a daisy chain, a network daisy chain between the screens. Now you've dramatically reduced the number of ports you use at your switch. Your network has got dramatically easier. The number of cables that you've got has got dramatically easier. And if you pull out one network cable, nothing happens because the same signal is going both ways around the loop. You don't even drop a frame on any of the screens. That's an extra bit of confidence in your installation. You could also, if you've got multiple sources along the bottom, as I have there, I've shown 5 there, you could say, well, all of the screens are receiving all of the content. I can just, through the network, tell a screen which bit of content it's supposed to be showing. This is, again, a dramatically different way of doing our routing of content. And it's dramatically reduced the number of ports on the switch that we might have thought about. Very simple to provision the cable. So, what you will find is that if you talk to switch manufacturers, Netgear or someone like that, they will say, daisy chain's not a good idea. They are not talking about this. They are talking about daisy chaining switches, which is not a good idea. It confuses the switches. So they would recommend a leaf and spine network, so do I. This is not what they're saying don't do. This is a daisy chain of the network, of the screen links. Another approach would be actually to have 2 switches, a red and a blue network. They are 2 identical signals to each display, and now you've got even better redundancy. This is something that was created by ST2110 and inherited into IPMX. You don't need to do it, but if you put 2 network switches and have the right intelligence in your devices, even if a switch fails, you don't drop a frame. Now, there are some events where that's exactly what you want. The Prime Minister is making a big announcement in a conference. There's not going to be a take 2. You cannot possibly, the consequences of the screen going down are not worth considering. Yeah. So the expense of an extra switch is an easy decision. And that, I think, is enough to give you a taster of why we would want to move from SDI into AV over IP and specifically into IPMX. It's happening now, it's happening around you. There's lots of manufacturers now who are bringing that in, including Matrox. If you'd visited our booth at ISE, you would have seen KVMs that were IPMX based, wall controllers that were IPMX based, lots of signal routing that was IPMX based. It's now woven into our whole product range as it is into other brands. So I've left plenty of time for folks to say, I didn't understand that bit. Can you tell me some more about, have you thought about? This is a great story, and the future happens when you start to say to clients, have you thought about IPMX? Have you thought about what might happen if? Because IPMX gives you the options for dealing with it on the fly. that's me finished. So I can see a microphone moving out into the floor. If there's anyone who's got things that they would like clarified, repeated, or otherwise expanded, now is the time for asking it. Well, maybe I'll ask myself a question. What shall I say? Do you need a particular switch to use it? No, you don't. It should work with a standard switch of whatever your favourite switch is. But as with all switches need to be configured. Some of the leading switch manufacturers are now putting an IPMX button in their configuration menu, so that in order to make that switch fit, you just go into the configuration menu and say, IPMX please, and then you can be sure that the switch is set in exactly the right way for what you want to do. What's coming next, Rob? What's coming next in IPMX? As I said, there were lots of things that were in draft there. So USB is one of those things that is being actively worked on now, because we all have devices that's one of those other connectors, wasn't it? I mentioned that, USB. So yes, that will be inside the IPMX, so that now you can have devices that are maybe connecting in room through their USB, connected through the network to somebody else who wants to watch them. Maybe you want to set up a device that's in a rack the other side of the stage, but you're in a control booth at the other end of the auditorium. You'd be controlling that through the network. Oh, still no. Oh, yes, a question. Yes, thank you.
So Matrox was very early with IPMX support, but you're now saying that there are different manufacturers with products on the market. Mm-hmm. Is there a list somewhere with all those products?
Well, there isn't a list for the reason I explained. Even Ames would probably knows about half of the people who are working on it. How do I know that? Well, I can see who's talking to the intermediary companies, the people who make SDKs and so on. And if I can see who's talking to them, and I can see that very clearly just by walking around a trade show, I know who's talking about it. I can see who's released products, but there's no point in producing a list and then saying it's incomplete. We try to do that at trade shows. We say, here's some places you can see it. But sometimes even the companies we know are doing it don't come back to us with a description. And these are big companies. Panasonic, you've all heard of Panasonic. I know that they've got IPMX in their world. I know it was on their booth. It was there for everybody to see. But when we asked them to say, what are you showing that's IPMX, they were too busy arranging other things on their booth to reply. So their name didn't go onto the list of who's got it. Who was on that booth that I showed you a picture of? The Plexus AV were there, the Cobalt were there, numerous other manufacturers were there, Barco was there. There were lots of manufacturers who are doing it. It would be fair to say that pretty much all of the LED wall controller people either have announced that they're doing it or have announced that they have got it. So yes, does that sort of answer the question?
Yeah, I guess you could say that, for example, Dante and NDI have been very good at marketing products that support their technology, and it's probably a good idea that Ames also do more effort on that.
Yeah, absolutely. One of the things that you can say about Ames is it doesn't, because it's not based on a chip, it doesn't have the big marketing departments that, say, Dante has got, or the HD-based T Alliance. So we do what we can. We run workshops, we run conferences, and folks like me run around spreading the word. So it's the manufacturers are picking it up, and what we need now is their customers to start saying, "I've heard about this." And I'm greatly encouraged by the fact that people walk onto trade show booths now and say, you probably don't remember me. I spoke to you last year about this IPMX thing, and I'm sorry to say I put it out of my mind as soon as I walked off the booth. He didn't think it was important then. And then he says, I've come back. People are asking me, can we start again, please? And that's really encouraging. And the fact that products are being won precisely based on the options that IPMX is delivering. I like to think of it as this way. If a tender ever goes out to supply something, you quite often see things that are broken down into a list of must-haves and a list of nice-to-haves. Some tenders have a third category, and this is a really interesting one, should-haves. And when I first saw it, I thought, what's that all about? And I contacted the people and said, what's a should-have? And they said, it's really easy. It's a must-have that we don't need on day one. And that's exactly what IPMX is. Not only should it be on the list, it's not a nice-to-have. It's not something, oh yeah, we forgot about interoperability. We just thought things would be interoperable. It's really a must-have, but we don't need it on day one because nothing's going to go wrong on day one. And that's a very interesting way to think about it. How often do we specify should-haves? Not often enough, I think, is the answer.
Yes. A few years ago, Dante video came out, which as far as I can tell, is not based on the 2110 standard. How do you prevent the ever-expanding amount of, let's make a new protocol to solve an issue, and suddenly there's 25? How are you working to move the entire industry into this one to prevent the spread?
There's no great benefit in having an ever-increasing number of standards. You know, that defeats the object. So you try and work with the standards that are covering the most number of options. If you look at NDI, yeah, they've got 3 flavours, and they're all in what I would have called the highly compressed environment. Yeah, they're all in that 1 gig network. That's why NDI is used in broadcast, but only in areas where they can accept the compromises that are in that band. There are 3 Dante AV variants spread across the bottom 2 rows. So we've got to accept that there are different user needs clusters. Manufacturers have always made products trying to satisfy clusters. So that's the way you follow it. You follow the clusters. And if something new comes up, you have to take a decision. Are we going to try and address that? Maybe we need to have another category of non-standard codecs. You know, maybe that's a possibility for the future. Somebody who likes the idea of the transport being universal, but wants to have their own proprietary bit inside the universal transport. That may well answer the need of that by saying, well, okay, if there's enough reason for it, let's bring it into the family. IPMX is not out there saying, don't join. It's saying, please do join.
Like NDI, you have lots of software you can run on your computer. Do there exist anything like that for IPMX?
I have to say NDI have done a wonderful job in getting together a world of software applications, and that's an inspiration to what we may do. And part of my job is talking to those software companies, saying, look, IPMX is happening. Yeah, wouldn't you like to have a pull-down menu that says select IPMX? And as I talk to them, they say, oh yeah, why didn't we think of that? So I think it's a great idea. I think there should be lots of tools that are around it. The tools already exist. It's just a matter of getting the people who make those tools to widen their view of what's a should have. Good question. I like that one. In fact, they've all been good questions, especially the ones I asked. Any more? Oh, he's on the ball now. You can see the cogs are whirring.
Maybe not a question, but it's important to realize that NDI and Dante are proprietary protocols delivered by a single company. So if something stops working, you are relying on that single company to fix your problem.
That's absolutely true. And let's also turn it the other way around and say that IPMX does not have a chip in the middle. IPMX could be software, it could be FPGAs, it could be an ASIC. But the idea of saying, well, yeah, this is what I'm using NDI in my facility. I've got 200 units. I'm not going to pull them out. Of course, that's the case. So the excuse me, I thought I'd turned that off. So yes, I've got the NDI units in my my facility. I've got to keep using them. That means you want to bring NDI somehow into the fold. NDI is not totally closed. You know, you can create a gateway that will take NDI in, extract the essences. This is a network device, not an endpoint device. You're not coming out through HDMI. Extract the essences and then put them into the IPMX network. Equally, you could put them into other networks as well. And those sort of conversion products exist, including from Matrox and others. So we call them IP to IP gateways, because they're network devices. But that's a way of bringing other things into the fold and addressing that lack of direct interoperability in a different way that leaves it in the network. But there's always room for other ideas of what could be done. I mentioned all those people who work with the VSF and with AMWA and so on. They're always looking for representatives of other bits of the ecosystem, the users, the integrators, the rental companies, to join in and say, yeah, we've got some ideas. Have you thought of this? Because without ideas, you don't go anywhere. I think we've worn them out. In that case, thank you all for coming. Oh my goodness, thank you very much.